moving on to Ohm's law, again we have just discussed all the formulas which we'll be using in current electricity chapter, but we still have to discuss one very important point, which is called ohmic and non-ohmic devices. What is this? Ohm's law, right? So from here you can always deduce that V is proportional to I. Fine. So if I make a graph like this is supposed to be the graph for what? Ohm's law, that V is directly proportional to I. This is for any conductor. Suppose I have a copper sulfate solution, that is CuSO4 solution, okay. There also, if you try to make a graph between voltage or potential difference applied with respect to current, the graph would still be a straight line. So should I consider that all those materials which have this straight line graph in which V is directly proportional to I are called ohmic conductors? Should I consider that? Let's see. Consider a case of water voltmeter. In water voltmeter, the graph is like this. The graph is a straight line, and if this graph is a straight line and V is also proportional to I here also, it's just that X intercept is somewhere else. Should it be considered into ohmic device? The answer is no. This is the graph for water voltmeter. No, it will not be, because there is another condition for ohmic devices in which number one, graph has to be straight line, and number two, it has to pass through origin. This graph does not pass through origin. So what do you mean by the graph has to pass through origin? That means if this is 0, this has to be 0. Here, when potential was 0, current was not 0, current was already something. That is why water voltmeter is not considered into ohmic devices. I would give you another example of non-ohmic devices. So here write the topic non-ohmic devices. Non-ohmic devices, you can give 2-3 examples. For example, diodes, Zener diode, especially diodes. This is how diodes graphs are. The forward biasing state would give you graph like this, and reverse bias state would give you graph like this and this. So basically, even if you don't go for the reverse bias state for now, even if I remove this part, the graph is not a straight line even if it starts from origin. This is for a diode, PN junction. The full name is PN junction diode, and this is the graph is, and this is considered under non-ohmic devices. So remember the last and final point, that if this is how a graph is and later it goes into a curve, so this is the part up to where Ohm's law is followed. So basically whatever property which is showing, whatever material this is, which is showing this type of deviation between V and I, it is following Ohm's law up to certain value, which after which it is going under non-ohmic conditions. So this is the difference, basic difference between ohmic conductors and non-ohmic conductors.